Welcome to this explainer. Okay, if you've been following the news lately, you've probably heard a lot of panic surrounding artificial intelligence. We're constantly hearing about existential risks, alignment failures, and this terrifying idea of machines just operating completely outside of human control. And it feels incredibly modern, right? Like this unprecedented crisis brought on by silicon and deep learning. But what if I told you that this exact anxiety is actually deeply rooted in ancient human history? Today, we're exploring a fascinating paper from Frontiers in Artificial Intelligence that completely reframes how we think about AI.
So let's dive right into this. Is AI a brand new threat or simply a very old mirror reflecting our own human tendencies? We often assume our panic over AI safety or kill switches and rogue robots is a uniquely 21st century problem. But the truth is, humans have been wrestling with the ethical dilemmas of creating artificial beings to act on our behalf for literally thousands of years. The technology has evolved, sure, from mythic bronze and clay to mechanical gears and now to code. But the core structural problem of how to safely delegate authority, that hasn't changed one bit.
Section 1. The Ancient AI Anxiety.
To really grasp our modern fears, just look at this astonishing pedigree. We're talking all the way from ancient Greece and the myth of Talos, to the 16th century Jewish folklore of the golem, to Charles Babbage's analytical engine in the 1830s, right up to modern generative AI. Humanity has been trying to outsource our protection and our labor for millennia. We've always craved intermediaries to do the heavy lifting for us, whether that's physical or cognitive. But whenever we design these proxies, we immediately run into the exact same governance problems.
Moving on to Section 2, Guardians and Kill Switches.
Way before we had computer code, we had myths that basically acted as early thought experiments. First up, meet Talos. According to Greek mythology, Talos was this giant bronze automaton designed by the god of engineering, Hephaestus, to protect the island of Crete and the goddess Europa. He was essentially programmed to circle the island 3 times a day and hurl boulders at approaching pirate ships. It was a highly effective, if kind of crude, security system. He was physically invincible, powered by this divine blood called ichor. But, and here is the critical detail, that life force was sealed inside his ankle with literally just a single bronze nail. So he was a highly capable system, but burdened with a catastrophic single point of failure.
So, how was a giant bronze robot defeated? Well, not by brute force, but by the ancient equivalent of an adversarial hacker. The sorceress Medea used magic to confuse him, unsealed that bronze nail, and just drained his power. Talos perfectly represents what happens when you have bounded autonomy without any moral context. He couldn't tell the difference between a pirate, a merchant, or a lost refugee. He just executed automated violence based on a rigid mandate. Think about how directly that applies today to things like autonomous weapons systems or algorithmic border control. It's the absolute danger of delegating coercive force to a system that is totally incapable of contextual judgment.
Now, let's fast forward a bit to 16th century Jewish folklore and look at a slightly more sophisticated governance model, the Golem of Prague. Created by Rabbi Loew from mud and clay to defend his community, the Golem wasn't autonomous by default. It was activated by placing a shem, which is a mystical inscription, in its mouth or by writing the Hebrew word emet, meaning truth, right on its forehead. Crucially, the creator built in a deactivation method. By simply erasing the first letter to spell met, meaning death, the golem would instantly deactivate.
Now, what's really interesting here is the contrast between these two ancient systems. Talos had a rigid mandate, zero flexibility, and absolutely no safe override. Once he was on, he was on. The golem, on the other hand, featured conditional activation and an explicit override mechanism. It's basically a perfect historical visualization of human-in-the-loop control. When the golem completed its task, or if it ever started to go a little rogue, Rabbi Loew pulled the plug. The accountability remained firmly with the human creator, not the clay.
And this brings us to a foundational concept for this whole topic: delegated agency. This is when artificial agency is authorized and constrained by human actors for a very specific purpose. Systems, whether they're made of bronze, clay, or complex neural networks, may exhibit agency. They might take actions, solve problems, or generate a block of text. But moral authority, that always remains with the human delegator. We're the ones setting the parameters.
Section 3. Execution without understanding.
So what happens when these artificial agents start mimicking intelligence so well that we forget they don't actually understand what they're doing? Well, long before computers, engineers were formalizing delegated action through mechanical constraints. In the 13th century, Al-Jazari designed these incredible programmable automated water clocks and mechanical servants. Later on, Leonardo da Vinci built a mechanical robot lion that could actually walk and present flowers. These were intricate marvels of mechanical sequencing, for sure, but they were entirely predetermined. They acted without any adaptive judgment. They executed tasks flawlessly, but they were completely empty of intent.
Perhaps the most stunning historical example, though, is the Jacques-Droz Writer, built back in 1768. It's this programmable doll made of over 6,000 parts that sits at a desk, dips a quill in ink, and flawlessly writes out custom 40-character texts. It even blinks its eyes and moves its head around as if it's in deep thought. But it has absolutely zero semantic awareness. It manipulates symbols perfectly without knowing what any of those symbols actually mean. If that sounds incredibly familiar, it really should. It is an exact 250-year-old historical parallel to the generative AI models we use every single day.
And this brilliantly illustrates a point made by Ada Lovelace, the world's first computer programmer, way back in the 1840s regarding Charles Babbage's analytical engine. She wrote, "The analytical engine has no pretensions whatsoever to originate anything. It can do whatever we know how to order it to perform." Lovelace realized early on that a machine can manipulate symbols with breathtaking complexity, but it does not originate thought. The real magic? That's in the human instructions, not the machine itself.
Section 4. The illusion of life.
If these machines don't actually originate thought, why do we consistently attribute real emotions, intentions, and morality to them? Honestly, it comes down to a deeply ingrained psychological tendency, which is best captured by the myth of Pygmalion and Galatea. Pygmalion was a sculptor who carved a statue of a woman out of ivory that was so beautiful and lifelike he fell madly in love with it, which, is certainly a choice. But we do the exact same thing today when we interact with a conversational chatbot that tells us, "I feel happy to help you." We project empathy and intention where there is literally only statistical probability and code.
So the crucial point is this. Projecting life onto AI isn't just some quirky human habit. It's a profound ethical risk. When we anthropomorphize AI, when we treat it like a moral agent that makes mistakes or goes rogue, we create what the paper calls responsibility gaps. We accidentally let the human creators, the data curators, the corporate executives, and the deployers entirely off the hook. We blame the artifact, and the real people responsible escape scrutiny.
Section 5. The true source of risk.
This completely reframes the modern AI alignment debate. The risk isn't the machine, the risk is us. Yes, modern AI adds incredible, unprecedented speed and scale, for sure. But the underlying ethical failures are driven by institutional fragmentation and distributed human agency. Our modern impediments are things like geopolitical multipolarity, competitive acceleration where companies are just rushing products to market, the rapid diffusion of open-source models, and varying legal jurisdictions. When a system causes harm today, responsibility is diffused across thousands of engineers and executives. It's an institutional failure of human coordination, not an instance of machine autonomy.
Section 6. Rules for proper delegation. So how do we actually build modern golems without losing control? Let's move on and see how this builds into an actionable governance framework with 5 clear rules. First, auditability. We absolutely must be able to trace training data and deployment pathways. Second, interruptibility. We need institutional kill switches. These are an ethical requirement, not an optional feature. Third, reversibility, meaning stage capability releases that can actually be rolled back if needed. Fourth, capability bounding, putting explicit constraints on model autonomy. And fifth, compute monitoring, oversight that is proportional to the risk of the system being trained.
To wrap up the main takeaway of this explainer, AI is basically a socio-technical mirror. It reflects our desires, our biases, and our governance structures. Despite the increasing technical sophistication of these systems, they do not constitute autonomous moral agents. They are sites of delegated human authority. We absolutely cannot outsource our moral accountability to our creations, no matter how advanced, autonomous, or human-like they appear to become. The responsibility remains irreducibly human.
Which leaves us with one final provocative thought to consider. We spend so much time worrying about the machines waking up and turning against us. But if artificial intelligence eventually leads to our downfall, who is really to blame? The machine executing its optimization function, or the masters who delegated their authority without bounds? Think about that the next time you ask a chatbot to do your work for you. Thanks for joining me on this explainer, and keep questioning the systems we build.